You got a way of making me stay, ay. You pull me closer when I push you away, yeah. So you the number one in my life, I won't move. Looking at the sky, heaven in my point of view. Hold up, wait, who competing with the moves? Whoa, got them singing like some oohs, yeah. Glory flowing like some hues, ayy. Gotta thank you, cause when I'm not killing it, you keep it reeling. You just like a fisherman, you help me reeling it. Your love is deeper than oceans I'm swimming in. Yeah, I was drowning, but now I can live again, yeah. It's a Saturday night, yeah. It's a holy night, yeah. It's a Saturday night, yeah. It's a holy night.
Late night with the candlelight, heaven bound, that's a big invite. Colorblind to the black and white, show you love and you feel alright. We ain't have time to cry, we fight. Shades on me, cut the future bright. Stuck together and we hold it tight. Stand down through the dynamite. All aboard on the freedom ride. Time to sail down the riverside. Kept going, never satisfied. Here the guy just glorify him, yeah. And I'm still trying to pray for no more violence. Matter of fact, we gon' need some guidance, yeah. Shine your light, shine your light, shine your light, yeah. All is calm, all is calm, all is bright, yeah. Shine your light, shine your light, shine your light, yeah. All is calm, all is calm, all is bright, yeah. It's a Saturday night, yeah. It's a holy night, yeah. It's a Saturday night, yeah. It's a holy night.
I don't know how else to tell you this. I thank you, Lord, you saved my life. I say your name and you listening. I almost love, you got me right. I came out the slums, the dealers, the users, the bombs, the scammers, the hustlers, and drugs. I had enough, I need that light of the love. I never run off on the plug. Off on the plane, life way too crazy. I need Saturday night for clarity. Looking for the light, oh you might as well come with me, help you find it. Blasting off astronaut ignited. Saturday night, take me to your highness.
Yeah. Baby laying in the manger on the first Noel, being treated like a stranger. On the first Noel, ain't no crowds or disciples. On the first Noel, flesh and bone just like you. On the first Noel, Noel, the first Noel. Noel, the first Noel, creation.
It's the advent of Cyber 2023, and we are on a mission to save Christmas. McGreedy, you are going down. I have the THM Army with me. Let's go. Yeah. I'ma pop a shell, but not what you think. Who am I root? Make it dead, a leg sink. We are on a mission, we're here to save Christmas. McGreedy's going down, forget about the riches. Rumors gone around, McSkitty's got snitches. It's an insider threat, and everyone's suspicious. Recon McRed is hunting down a witness. He says he needs our help, so power on your system. Get your black hoodie, boot up the attack box. Hackers come together and take command of the SOC. It's the THM Army, McGreedy will get caught. From the 0x1 all the way up to the gods. And it is time. What is up, everyone? My name is Tyler Ramsey. We are on a mission to save Christmas, and in this stream, we're going to continue working through TryHackMe's Advent of Cyber challenges. And hey, if you are new here, one of your first times being here, I want to say welcome, whether you're watching me live or after the fact on YouTube. Do just want to remind you that I am streaming right now to 3 different platforms. We are streaming on YouTube, Twitch, and LinkedIn, and I'll do my best to keep my eye on the chat on all 3 platforms. If you say something I don't see it right away, just give me a few minutes. I will eventually see it. But what we've been doing is every single evening so far in the month of December, we have not missed a day. We have gone into TryHackMe's Advent of Cyber challenges, and today is no exception. We are going to dive into day 16, which, based on the description, we are going to bypass some CAPTCHAs with machine learning. So without any further ado, let me share my screen and we will dive into it. I'm going to read it all in its entirety. I will be your audiobook, and we will work through this together. I want to say a special hello to Art Lover, Justin, and Hacks Guy, and Teraflops. Let me see if I'm missing anyone else on LinkedIn. I know there's a lot more people than that watching based on the stats, but a lot of people are too afraid to chat. So, if you are watching, hey, let me know in the comments if you're doing this alongside of me, what you think of Advent of Cyber, or what you think of the greatest rap song of all time, which is the one you just heard. I'm a Papa Shell, but not what you think. Who am I? Root, make your data leg sink. I know, like Tupac level right there. There's my Advent of Cyber rap song that you guys heard. And yeah, a little bit earlier tonight, for those of you a little bit confused, the time has not changed. It is an hour early, but the reason for that is the UFC's on, and I'm a huge fan of the UFC. There's an incredible pay-per-view card tonight, and I want to watch those fights. So I was like, as soon as I get my kids to bed, I'm jumping on stream because Christmas isn't going to save itself, but then I need to watch the UFC. So I'm starting a little bit early so I can watch the UFC. Let's go ahead and dive on in. Who's fighting tonight, Hacksai? Well, let's preview it. There's actually a lot of good fights now that you asked me. We have Leon Edwards versus Colby Covington. That's going to be a good fight. My heart, I know most of you don't care about this, but it's my live stream, so we're going to talk about the UFC. My heart wants Leon Edwards to win. I think Colby Covington might win, though. His pressure and his wrestling just unrelenting. But I hope I'm wrong. The flyweight, I think this dude's gonna win. Welterweight, once again, like, my heart says Stephen Thompson. Really love Stephen Thompson. Hope he wins, but that dude looks like a solid contender. But I love Wonder Boy. We got Paddy Pimblett and Tony Ferguson. My heart says Tony, but dude's been getting beat up like all the fights. But he used to be incredible, right, before he kind of got beat up by Justin Gaethje. We got Paddy Pimblett. I think it's going to win that. But, guys, even on the prelims, we have some really good fights. Like Cody Garbrandt on the prelims, what? And I'm going to miss it because that fight is happening right now, and I'm not going to live stream it and get my Twitch account banned. So I'm going to have to watch the highlights on the Colby Garbrandt fight, since that is apparently, well, hold up. So prelims start at 7. That's right now. So it's usually 7, 7:30, 8. So his fight may not start till 8 or 8:15. So we might have time if we can do this. But yeah, this is what I'm looking forward to, guys. So I'm going to be watching this as soon as we are done saving Christmas. But without any further ado, because I know a lot of you could care less about the UFC, let's go ahead and dive into things. Can't capture this machine. So McGreedy has locked McSkitty out of his ELF HQ admin panel by changing the password. To make it harder for McSkitty to perform a hackback, McGreedy has altered the admin panel login so that it uses a CAPTCHA to prevent automated attacks. A CAPTCHA is a small test, like providing the numbers in an image, that needs to be performed to ensure that you are a human. Curious if anyone's had the CAPTCHA. I wonder if I can find it. There's a CAPTCHA that says, like, CAPTCHA, which animal is bigger? Okay, it's this CAPTCHA. Guys, I can't solve this CAPTCHA. This one. Have you guys ever gotten this CAPTCHA? No matter what you do, it's the wrong answer. It's the silliest CAPTCHA. Be like, hey, which animal's bigger? What's a smiling dog? Some of these CAPTCHAs are absolutely insane. That's what I think about when I read about CAPTCHAs. But after the great success of using machine learning to detect defective toys and phishing emails the last 2 days, McSkitty is looking to us to help him build a custom... McSkitty's a her, isn't it? I think McSkitty's a girl. So help her build a custom brute force script that will make use of ML to solve the CAPTCHA and continue with the brute force attack. There is, however, a bit of irony in having a machine solve a challenge specifically designed to tell humans apart from computers or machines. So what are our learning objectives today? Complex neural network structures. How does convolution neural networks function? Oh my goodness. Using neural networks for optical character recognition. Integrating neural networks into red team tooling. I understand that completely. Terraflop said McSkitty is a female. Was a typo. Okay, that's kind of what I figured. I was pretty sure McSkitty was a lady. All right, we have this. So I need to start the VM, and I did that. I just have it in a separate tab. So here's the VM right here. We'll tab back and forth. Introduction. Today's task will get our first look at how red teams can use machine learning to help them attack systems. But before we can start attacking the admin portal, we'll need to expand on some ML concepts taught in the previous task. And do just want to give a little bit of real world syntax, or not syntax, context with this. I'll often discover CAPTCHAs when I'm doing a pen test. What I've noticed about organizations is they will actually do the Google CAPTCHA itself incorrectly. And what I've been able to do more than once is I solve the CAPTCHA once, send that over to Repeater and Burp Suite or Intruder, and I can spam that, just including the same CAPTCHA answer. And although they have a CAPTCHA in place, it doesn't validate anymore. So I've fully bypass their CAPTCHA. So sometimes you don't have to use machine learning. They just misconfigure the CAPTCHA, answer it once, and you're good to go as long as you repeat that request. If you're doing a bug bounty or a web app pen test, if there's a CAPTCHA, try that. Try answering it once and then just resending that request after you've answered it. And I've had a handful of times where that works on actual Google reCAPTCHA. All right. Convolutional neural networks. In the previous task, we talked about neural network structures. However, most of these structures were fairly basic in nature. Today, we will cover an interesting structure called a convolutional neural network, or CNN, not to be confused with Fox. CNNs are incredible ML structures that have the ability to extract features that can be used to train a neural network. In the previous task, we used the garbage in, garbage out principle to explain the importance of our inputs having good features. This ensures that the output from the neural network is accurate, but what if we could actually have the neural network select the important features itself? This is where the CNN comes into play. In essence, CNNs are normal neural networks that simply have the feature extraction process as part of the network itself. This time, we're not just using math, but combining it with linear algebra, and everyone who was in math class in high school just had PTSD from that, but that's okay. Again, we won't dive too deep into the math here to keep it simple. So we can divide our CNN into three main components: feature extraction, fully connected layers, and classification. We've actually already covered the last two components in the previous task as a simple neural network structure, so our main focus today will be on the feature extraction component. Awesome. All right, let me make sure I'm not missing anything in the chat. Over on LinkedIn, we have Serhi, if I'm saying your name right. Thank you for joining. Let's keep going. Feature extraction. CNNs are often used to classify images. While we can use them with almost any data type, images are the simplest for explaining how a CNN works. This is the CAPTCHA that we are trying to crack, 40531. Since we'll be using a CNN to crack CAPTCHAs, let's use a single letter in the CAPTCHA as our image. So we have this 4 here. The first question to answer is, how does a CNN actually perceive this image? Remember, it's a computer. The simplest way for a computer to perceive an image is a 2D array of pixels. A pixel is the smallest area that can be measured in an image. Together, these pixels are what create the image. A pixel's value describes the color that you are seeing. So RGB, 0 to 255 in grayscale. So to represent it, we start at the top left value of each pixel, working our way to the right in rows before moving down. Okay, I see. So we start here, and we're slowly kind of simplifying it so that we can map it out on a computer. Convolution. Now, there are 2 steps in the CNN feature extraction process that are performed as many times as needed. The first step is convolution, is actually how you say it. Convolution. The math is about to get slightly hectic here, so take a deep breath. And let's dive in. During the convolution step of the CNN's feature extraction, we want to reduce the size of the input. Images often have several thousand pixels, and while we can train a neural network to consider all of these pixels, it will be incredibly slow without really adding any additional accuracy. Therefore, we perform convolution to summarize the image. To do this, we move a kernel matrix across the entire image, calculating the summary. The kernel matrix is a smaller 2D array that tells us where in the image we are currently creating our summary. This kernel slides across the height and the width of the image to create a summary image. Take a look at the animation below. So we're kind of scanning it as we do that. I got you, bruh. All right, as you can see from the animation, we start at the top left of our image, looking at a smaller 3x3 section. We then calculate the summary by multiplying each pixel with the values in the kernel. These kernel values can be set differently for different feature extractions, and we're not limited to a single run. The values of these kernels are usually randomized at the start and then updated as the network is busy training. We say that each kernel run will create a summary slice. As you can see from the animation, by sliding this kernel across the entire image, we can create a smaller summarized slice of our image. Now, there are a couple of reasons why we want to do this. One, as mentioned before, we create a neural network that takes each pixel as input, but this would be an incredibly large network without improved accuracy. The summary created by the convolution process still allows us to capture the image's important details without needing all the pixels. That makes sense. If our accuracy decreases, then we can simply make the kernel smaller to capture more details during the input phase, so we know that after testing it. The term used here for this process is sparse interaction, which is how many of us interact with people, as the final neural network won't directly interact with each pixel. Man, I crack myself up. If you would, probably only me, I probably only laugh at my own jokes. If you'd like to learn more, you can read here. If we calculate a feature in one location in our image, then that feature should be just as useful as a feature calculated in another location of the image. Making use of the same kernel to determine the summary slice means this condition is met. Now, if we update the weights in one of our kernels, it will alter the summary for all pixels. This results in something called the property of equivariance to translation. Simply put, if we change the input in a specific way, the output will also get changed in the same way. If you'd like to learn more, you can read here. That'll be beyond my head, but I think I'm kind of understanding it. We perform the summary creation with several kernels to create several slices that are then sent to the next step of our CNN feature extraction process. Justin said, no, that made me smile because of the truth in it. I didn't make you laugh, but at least I made you smile. I'm here all month, folks. Pooling. The second step performed in the CNN feature extraction process is pooling. Similar to convolution, the pooling step aims to further summarize the data using a statistical method. Let's take another look at our single slice and how max pooling will provide a summary of the values. All right. We got that. COE9. I see. So it's summarizing. It's trying to summarize this whole thing. I got you. As you can see again, for each kernel, we create a summary. And that's it. It determines its own features. Okay. Fully connected layers. Now that we have our features, the next stage is really very similar to the basic neural network structure that we used back in the introduction of machine learning task. We shall create a simple neural network that takes inputs, the summary slices from our last pooling layer, run them from the hidden layers, and then finally provide an output. This is called the fully connected layer portions of the CNN, as this is part of the neural network where each node is reconnected to all the other nodes in the next layer. 10.4, classification. Lastly, we need to talk about the classification portion of the CNN. This is the output layer. So remember, we have input, hidden, output. So this is the output layer from the fully connected layers portion. In the previous task, our neural network only had one output to determine whether or not a toy was defective, so 0 or 1, or whether or not an email was a phishing email. However, to crack CAPTCHAs, a simple binary output just won't do, as we need the network to tell us what the character and later the sequence of characters is. Therefore, we'll need an output node for each potential character. Our CAPTCHA example only contains numbers, not letters, so we need an output node for 0 to 9, totally 10 output nodes. Having multiple output nodes creates a new interesting feature for our neural network. Instead of simply getting one answer now, let me zoom in. All 26 outputs will have a decimal value between 0 and 1. We'll then summarize this by taking the highest value as the answer from the network. However, nothing is stopping us from reviewing the top 5 answers, for instance. This can help us identify areas where our neural network might be having some issues. For example, there could be a little confusion between the characters M and N, which my son is just learning letters and reading, and I can assure you there is confusion there, even for people. Reviewing the output and W as well. W is a tricky one when you're just learning. Reviewing the output from the top 5 nodes will show us that this might be a problem. While we may not be able to solve this confusion directly, we could actually use this to our advantage and increase our brute force accuracy. We can do this by simply discarding the CAPTCHA if it has an M or an N and requesting another one to avoid the problem entirely. All right, Zach. So what's up, Ty? What's up, Zach? Thanks for being here, my friend. All right, training our CNN. Now that we've covered the basic, let's take a look at what will be required to train and use our CNN to crack the CAPTCHAs. Please note that the following steps have already been performed for you. Thank you. The next steps will be to perform in the hosting the model section. However, understanding how training works is an important aspect, so please follow along and attempt the commands given. Okay. So we'll do these commands anyways. Yeah. We'll be making use of the attention OCR for our CNN model. This CNN structure has a lot more going on, such as LSTMs and sliding windows, but we won't dive deeper into these steps in this instance. The only thing to note is that we have a sliding window, which allows us to read one character at a time, so think of like your eye test things, instead of having to solve the entire CAPTCHA in one go. We'll be making use of the same steps file to create CAPTCHA 22, which is a Python pip package that can be used to host a CAPTCHA cracking server. If you're interested in understanding how this works, you can have a read here. Well, you can try to run all this software yourself. Most of the ML components run on a very specific version of TensorFlow. Therefore, to save us tears, making use of the VM attached to the task is recommended. In order to crack the CAPTCHAs, we'll have to go through the following steps. So gather them, so we can create labeled data. So that's the ingestion, if you remember from last night. Label them to be used in a supervised learning model. And that supervised learning model, remember we talked about that again last night. Train our CAPTCHA cracking CNN, so we have to train it, verify and test it to see if it's accurate, export and host it so we can feed it CAPTCHAs, and finally, create and execute a brute force script that will receive the CAPTCHA, pass it on to be solved, and then run the brute force attack. Which once again, if your password protection, or not password, your login screen is only protected by CAPTCHA, you need to add more. That's the whole thing of defense in depth. You should have a CAPTCHA in place, maybe account lockout in place, and an IP block in place based on invalid attempts. Each one of those can be bypassed in a myriad of ways, but when you have all of them at the same time, you're making the attacker's job more difficult and increasing that pyramid of pain that they talk about on the blue team side of things. Steps 1 or 4 are quite taxing, so they've already been completed for you. We'll do a quick recap of what these steps involve before moving on to hosting the model and cracking some CAPTCHAs. To do this, you have to start the Docker container. In a terminal window, execute the following. All right, so I am just going to copy and paste this. Oh, let's get the right one open. And I'll try to zoom in for you guys a little bit. Cool, so we can see it running. Beautiful. Oh yeah, Docker PS, that's what I just did. And now we're going to drop into a shell on it. Wait. I'm doing my syntax, my Docker syntax wrong there. Yeah, there we go. And then we're in a shell in our Docker container, and then cd ocr. Okay, so we have labeling, labels, model, raw data, training. So that should all stand out to us. Gathering our training data. In order to train our CAPTCHA cracking CNN, we first have to create a data set that can be used for training. Let's take a look at the authentication portal for HQ admin. Open that in a browser window and we'll see this authentication page. Oh, okay. It automatically opened to it. Mick. Incorrect CAPTCHA. That's how we know it's incorrect. I can't even do it, and I'm not even a robot. As we can see, the authentication portal embeds a CAPTCHA image. We can get the raw image using a simple curl command from a normal terminal window. And there it is, the base 64 encoded image. And the output, yep, that's what I said. We can write a script that will download this image and then prompt us to provide the answer for the CAPTCHA. That's already been done for you. You can view the stored data using the following command in the Docker container. Okay, so they've already done that. I got you. So let's go back to our Docker container. Oh, I shouldn't have done ls. Okay, there's all of our images. Got it. So they've already done that for us. Once we have our text file, it has to be converted into a TensorFlow record that can be used for training. And this has also already been done for you, but you can use the following command to create the data set. Okay, let me see where that's at here. Is it training? Oh shoot, I should have done that. Oh, it's in labels training.txt, training.tf records. That's what we're looking for. You know what? I'm just going to run the command because I'm not seeing it. Or is it one? Oh, it may be one directory up, actually. Oh, well, we'll just give it a shot to run. As mentioned before, this has already been done for you and is stored in the labels directory. Maybe Tyler, you should just learn how to read. That would be a good starting spot. It failed anyways. Okay. There it is. Testing.tf records. Got it. Training and testing the CNN. Finally, we can start training our model. This has already been done for you, but with all the preparation completed, you would be able to use this command to start the training. So it says it's already been done, but we're just going into labels, AOCR, train, and then we're training based on those records. Training will now begin. Once the training has completed a couple of steps, stop and press Control C. Let's look at one of the output lines from running the training. Am I supposed to train it? Let's train it. Just so we get the full process. All right, we'll just let the thing train while we continue to read. Stop it. So once the training completes, stop it. So starting the training process, so it's not completed yet. In each of these steps, the CNN is trained on all of our inputs. Similar to what was discussed in the introduction to machine learning task, each image is given as an input to the CNN, which will then make a prediction on the numbers that are present in the CAPTCHA. We then provide feedback to it on how accurate its predictions are, like good robot or bad robot. This process is performed for each image in our training dataset to complete one step of the training. The output from AOCR shows us how long it took to perform this round of training and provides feedback on the loss and perplexity values. A loss is a CNN's prediction error. The closer the value is to 0, the smaller our prediction error. Okay, that makes sense. Any loss value below that would show the network has either completed its learning process or overtrained on the dataset. How are we doing here? Still training, I think. Perplexity. Perplexity refers to how uncertain the CNN is in its prediction. The closer the value is to 1, the more certain the CNN is that its prediction is correct. You know, some people in this world, they are at a 1 and they're very much incorrect. Consider how perplexed the CNN would be seeing the image for the first time. Seeing something new would be perplexing. But as the network becomes more familiar with the images, it's almost if you can't show anything new. Any value below that would be considered a trained or overtrained CNN. Oh, so you can see this here. We have our loss and our prediction. I think those numbers are pretty good. We can probably stop it. As the CNN has already been trained for you, you can now test it. All right, well, we trained it too. That's probably why it had such good numbers already. Let's see how we do. Come on, machine ML, not MLM, not multi-level marketing. Okay, let's stop it real quick. So we have an accuracy of 99%, a loss closest to 0 that we can get, which is really good. Perplexity, less than 1.05. That's really good probability. Yeah, so this thing is a beast, although we had a weird one right there. The probability went down a lot, but perplexity went up. So that must have just been a harder image or something. But yeah, looks really good so far. As you can see from the testing time, running a single image is significantly faster than training it on the entire data set. This is one of the true advantages in neural networks. Once training has been completed, the network is usually quick to provide a prediction. As we can see from the predictions provided, one of the CAPTCHA predictions was completely correct, whereas another was a prediction error, making it a 5 for 6. Got you. If you compare the loss or perplexity values, you'll see the CNN is uncertain about its answer. We can actually use this to our advantage because, yeah, not submitting the CAPTCHA. So, you know, when you do a CAPTCHA, there's always that option, give me a new one. So that's what you do. Like if it's a one, you could tell the thing like, hey, if you're not certain, just request a new CAPTCHA. That's cool. So hosting our CNN model. Now that we've trained our CNN, we need to host it to send it CAPTCHAs through our brute forcing script. For this, we'll use TensorFlow serving. Let's check this out. Oh, so it's for machine learning model specifically. We're going to host it with that, probably with Docker, and expose it on a port. Got you. An export of the trained CNN has already been created for you under the OCR model directory. Now we'll now export that model from the Docker container using the following command. Okay. And all we're doing here is we're changing directory into OCR, and the and means, hey, if this command succeeds, then move on to this one. So CD, change directory to OCR, and copy the model to our temp directory. Once that's complete, you can exit the Docker container terminal and kill it using the following command. You can reuse Docker PS to get the container ID. TensorFlow serving will run in a Docker container. Let's make sure that actually went to our temp direct. Oh, there's our TensorFlow stuff. Okay, so we can exit Docker now. And now we are going to run the other one, our TensorFlow serving, and we're going to expose it on port 8501. That's really all that's doing. Fingers crossed. Okay, so far so good. Looks like it's starting up. Now we're finally ready to help McSkitty regain access to the HKey admin portal. We're now ready for our brute force attack. You've been provided with a custom script that we'll use. You'll find this custom script in the password list on the desktop in the brute forcer folder. All right, let's look at the script together. So what are we doing first? Well, importing libraries, requests, base64, JSON, and B64 is beautiful soup. All things that you would normally use to interact with a web server, especially requests here, and beautiful soup. JSON is so we can send the data in JSON format, probably for the username and password, and of course a base64 because we're base64 encoding the image. And so our username is admin. We know the admin username, so we must have gotten that through OSINT if this is a real world scenario, and we want to create this dictionary for passwords. We're going to send the passwords in there. We're putting in our URLs for our requests. So we have our website URL, but we also need our model URL, and I said that was exposed on port 8501, which you can see that right there. And so with openpasswords.txt, all this is doing is taking all of our passwords and we're importing the passwords in from our password list, and we'll check that out. We are putting them, removing the white space, putting them on separate lines, and then that's what the read lines does, puts them on separate lines. And then 4 line inlines, this could really be anything in Python. It could be 4 Tyler inlines, doesn't really matter. But of course, you want to make the code actually make sense. So it's saying for every line in lines, for every line up here, in other words, for every password, what do we want you to do? Well, we want you to append and replace the white space with nothing. So we don't have white space. I actually had this as an issue on a Try Hack Me room where you brute force a CAPTCHA. For that, it was math. So I had to write a, actually, I could show that to you guys. Hold up. GitHub.com. I did something similar for this, and hopefully this isn't too much of a giveaway for y'all. If you haven't done the room, you should do it. Let's see if I can find it. Is it this one? Oh yeah, so this is the username enumeration. So you had to write a Python script to do it. And I think people smarter than me did it in 2 ones. What I did is I first did username enumeration, and then I did password, really brute force attack. Here's my code on how I did it. But the biggest thing that threw me off for the longest time was there was a white space in my password I was sending over. So even though I thought, like I went through the full password list, it wasn't working, I had that white space there. So I just want to point out removing, or not white space, the tab line, removing that is huge. Okay, access granted equals false, count equals 0. So we're just setting that initially because we don't have initial access, and now we're setting our count to 0, so we have a counter going as we go. Run the brute force attack while we're out of passwords or have gained access. So while access granted equals false and count is less than the length of the passwords. In other words, if we haven't gone through all the password list and we don't have access, do this, right? Go through here and then add 1 to the count. We connect to the web app, so we get the CAPTCHA, so we can see that there using the request library that we imported there. We are just grabbing that CAPTCHA down, and we're going to send that CAPTCHA, of course, over to our CAPTCHA cracking thing. So it's all in the brute force thing. We build our JSON request to send to the CAPTCHA predictor. That makes sense right there. Send the CAPTCHA predictor request. So we're going to our CAPTCHA cracker and then going back to solve the CAPTCHA, and then we're sending that solved CAPTCHA back to it in order to do our passwords. But this is important right here. So we can increase our guessing accuracy by only submitting the answer if we are more than 90% sure. So remember, if our machine learning thing is not more than 90% sure that this is the correct CAPTCHA, we're just going to say, hey, prediction possibility too low, not submitting CAPTCHA, and we will get another one. Otherwise, we are doing this. We're sending a username, a password, our answer, and then submitting the query. And then it's just printing things out for us here. So if incorrect CAPTCHA value is supplied in response, print incorrect CAPTCHA, we'll resubmit this password. And that's big because we don't want it to try to submit the password when the CAPTCHA is incorrect. Like that reasoning has to be sound. Otherwise, we may very likely miss the password if we don't stop it from submitting the password to the wrong CAPTCHA. If the response tells us that we submitted the wrong password, we can try out the next password. So else if, that's what the elif is, else if incorrect username or password in response, print invalid credential pair, count +1. So we're adding 1 to our count up there so we can remember how many passwords we have attempted on this. Otherwise, we have found the correct password. Access granted. All right, I'm not going to dive into it. I just kind of walked us through that, at least my own interpretation of it. Let's run our brute force attack using the following command in a terminal window. So all we're doing is changing directory to home desktop brute forcer and Python 3 brute force. We're going to run it. So let's give that a shot. Whoops, wrong tab. Okay, so can I scroll up? Yeah, so we can see what it's doing here. Invalid credential pair, and look at this. Prediction probability too low. So that means the prediction probability was less than 90%. So it's saying, hey, we're not going to submit it. We're going to request a new CAPTCHA over and over again. We see that as it attempts to brute force. And here we go. We have our password of really not going to guess this. Same password, guys, I used for my TryHackMe account. Crazy how they do that. Let's log into this now. Why did that not paste? Okay. I guess I could type that. That wouldn't be too terrible to type, but there we go. All right, can we get the CAPTCHA? I think that's a 1, but it could be a 7. I'm going to go 31531. Access granted. THM CAPTCHA can't hold me back. Good work, team. Teamwork makes the dream work. Let's drop in that flag. And I do recommend the Red Team Learning Path. I think some of it may require a subscription, but that's one of the paths I have 100%ed on Try Hack Me. 100% of the Red Team path. Really, really good path for learning. All right, what key process of training a neural network is taken care of by using a CNN? I don't remember, bro. Please note. Feature extraction? Oh, yes, I'm right. What is the name of the process used in the CNN to extract features? Is that like the convolution crazy stuff? Yeah, convolution. I was right. I'm learning. What is the name of the process used to reduce the features down? I'm blanking on it, guys. It's on the tip of my tongue. Summarize. Oh, is it pooling? Yeah, I think you're right. It is pooling. Yeah, right there. Summarize the data. Because remember, we're taking kind of a summary of all of it. So we're pooling it together. That makes sense. What off-the-shelf CNN did we use to train the Python, to train a CAPTCHA cracking OCR model? I remember reading that. It was that Terra thing. Or is it attention OCR? Yeah, it must be what it is. Let's take a look at this though. Whoops, I didn't mean to leave the room. Gosh, dang it. Yeah, it's attention OCR. You know, if I could spell. What is the password McGrady set for the admin panel, which we have that. Really not going to guess this. Boom. And we are complete. We have completed, ladies and gentlemen, whatever day it is today. Is it day 16, I believe? We have completed day 16. I have not missed a day yet. I really hope I'm able to keep the streak up all the way through Advent of Cyber. We'll see. But the plan is I'll be back again tomorrow night. Same place, well, not same time. I'll probably be on a little bit later, around 8 p.m. But honestly, whenever I get my kids to bed, I'll probably jump on here. But guys, thank you for taking the time to hang out with me. I really do appreciate it. It is only 7:40. I still have time to watch Cody Garbrandt fight in the UFC. So I am going to sign off, and I'm going to go ahead and watch the UFC card for the night. But thank you, everyone, seriously, for taking the time to join me, whether you're watching me live or after the fact on YouTube. Thank you for being here. Hope you learned something in the process, and I will catch you guys in the next one. Peace.